Okay, so what's happening with us right now? We are now in our last chapter of the book. Okay, chapter 12. What is chapter 12 all about? It says here it's just a preview of what? Calculus. So if you're going to calculus juniors, you're going over next door next year, this will get your feet wet, ready to go. This is what they do. They basically do this chapter. That's where you start. And by October, you're into the new stuff. I can't help you there. Now, seniors, as you progress out of here, you go to college, your first freshman year of math, maybe you're in calculus. Well, this is going to help you.
Wait, there's a regular calculus class?
Not here.
Oh.
Well, I'm saying wherever you end up next year, if you're a junior, you could take calculus here. If you're going to college, you could take calculus in college. But this is your preview to calculus right here, chapter 12. Okay, and basically you are going to be doing what today? Finding limits using tables and graphs. There's 3 ways to do it. I'm just going to teach you this one and this one today. That's it. Algebraically, we can do it, but that will be Thursday. Okay? All right, so here we go. Why are we working with limits? I kind of told you, but here we go. Basically, it's this. It's a fundamental concept of calculus. Going into calculus, you want to know what a limit is, okay? Used for finding what? Derivatives and integrals. Okay? Again, you don't even know what that is, but you will by the time you walk out of here, May 20th or whatever, the end of chapter 12. Okay, so here's the notation that you need to know. It says, right here, this is, whoops, it's right here, my fault. Okay, how do you read this to yourself? You say, what's the limit of f of x, my function, when x approaches c? It will be exactly n. The limit is n. Okay, one more time. I'm going to read that to you. The limit of f of x as x approaches c is n. And it's written right here. Okay? What I just said was written there. Okay, what does it exactly mean? I'll show you. You might want to write this. You might want to draw this. And let's just keep it really simple. If your function is a line, what is the limit of your function when x approaches c? Well, you got to know what that number is. That's a number, c. So as x approaches, I'm just going to put c right here. There's your c. So what's the limit of your function? It looks like this. As you approach c from the right, as you approach c from the left, what's the limit of your function? Well, every time you come in from the left, this x value gets you that y. That's the answer. But you're getting closer and closer to what number? C. So as you get closer to c, okay, here's what you're going to get really close to this number. Okay, so you are working your way up the graph from the left this way. And that's going to be your limit. As long as the right side is the same number. So from the right side, you look here, 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 and all these answers, if you notice, you're coming downhill. You're coming downhill with your answers. You're approaching this number. What is that number? That's c goes into your function. What comes out? C goes in. What comes out? That's the limit. What is it? It says right here, it's what? It's n. It's a number. It's like 3, 4, 5, but it's n. And that is the limit. That's all it is. It's pretty simple. But it says here sometimes this limit is the same as f of c. F of c just means put the number c into your function and work it out. It's that easy. But sometimes it's not that easy. So we'll have to look at a bunch. Okay? All right. So how do we get the limit? There's a couple ways. One of them is numerically, using a table. So if I asked you this, the limit of f of x as x approaches 3, how would you do that? Using a table? Let me just put 3 here. We'll call this your limit. What's the limit at 3? Well, you have to move in from the left. So you want to get closer and closer to 3 from the left. What would be pretty close to 3? 2 is close, but let's get really close. 2.9. So you could try 2.9. You could try 2.99. You could try 2.999. And you can just keep getting closer and closer. By the way, you'll be doing this with your calculator. Okay? You're coming in from the left. Now come in from the right. From the right, it's going to be what? 3.001, I heard. That's really close. A little further out and a little further out would be that. Okay. So you will basically do this over and over, and then you'll notice that these y values get close to some number. We'll call it what? We'll call it n. As x approaches 3, what's the limit? It's going to be this number, whatever this number is. Okay? How else can you do it? You can do it by graphing. I already showed you a graphing one. I'll show you another one. Okay, there's another one. Let's say as x approaches 3 on this one. So here's a function. What's the limit of this function as x approaches 3? Right here. Well, this time I'll actually give you an answer. So as you come in from the left side, the answers are here, here, here. So you're moving this direction from the left, and you know this is really the answer, but you're approaching this number. As you come in from the right, you're approaching this number. Well, that number is what? Make a number up. 4. So the limit is 4. That's it. That's all it is. You get the idea of what a limit is? You come in from the left and the right, and you go like this. What's that number I'm pointing at? Well, you got to look across and say, it's 4. It's 7. That's it. Okay? Analytically, you can do it using your algebra skills. Your algebra skills are like factoring and canceling and plugging numbers in. So this is actually taught to you in section 12.2. You will like this. You will like this because this is just basically your pencil moving and you just work it out and you figure it out. Okay? These are more visually seeing it. Okay? This is coming up Thursday. All right. Here we go. It's your turn to start working. These next graphs, or these next problems, they've all been graphed for you. Pretty soon here I'm going to make you graph them, and not you, your calculator. Okay. Oftentimes a graph will tell us whether the limit exists or not, and maybe what that limit is. Okay, so you look at that graph, and that graph is basically this right here. This is your function f of x. It's already been graphed. What's the limit? As x approaches what number? 0. Look over. Some of you probably see it right away. Here's 0 on the x-axis. As you come in from the right, as you come in from the left, you know all these answers are happening. So you're moving here, you're moving downhill, you're approaching that number. On the left side, you're approaching what? The same number. What is that number down there? What? Yeah, 3. So your limit is 3. That easy. You just look and go, where am I approaching? Right, that point. I'm getting close to that point. And that point has a y value of 3. Question? No hands. Keep going. Here's another graph. Here's another graph. Try to get the limit. Although this, yeah, it says right here. What's the limit of your function as x approaches 2 on both graphs? John, what do you think about this one? Do you have the limit?
Seems like,
Eddie?
2.
He says he thinks it's 2. Is he right? Okay, let's try it. As x approaches 2, here's 2 right here. So I'm coming in from this direction, and then I'm going to come in from this direction. When I say come in, I just mean put x values in. If I put -3 in, I'd get this answer. If I put in -1, I get this answer. If I put in 1, I get this. As you see, you keep getting closer and closer to what number? That point right there. That point corresponds to that number, 2. But for that to happen on the right side, you have to also be approaching 2. Look at all these points. Here, 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 here. You're going this direction towards that number 2. Is it still 2? Yeah, no, sort of, kind of. Yes? Yeah, it still looks like it's approaching 2. 2 is it. Okay, next. What's the limit of this function? It's got an open circle here and a solid dot up there. Everett, what do you think? He says 3. Hands up if you agree. We have 4, 5 people, 6. Okay, and then there's some of this going on. I don't know. Who says it's 2? Nobody. All right, here we go. As you come in towards the number 2, as x approaches 2, if you tried 4, you get that answer. If you tried 3, you get that answer. You tried 2.5, you get that answer. So all your answers are climbing hill, and they're heading towards what number? What are they heading towards? They're heading towards 2. Hang on. For it to be 2 on the left side, it's got to be heading towards 2. So let's try 0. I get that. 1/2, I get that. 1, I get that. 1.5, I get that. Your answers are going towards what number? They're going towards 2. Why'd you say 3?
Because 2 is another line.
Because 2 what? When you looked up, you went like this, didn't you? 2 goes up. Does that point exist? No. Does that point exist? Yes. If I was talking about the function, if I just said, what's the answer to this? F of 2, you'd put 2 in and you'd go, nope, that's not the answer. 3 is the answer. But I'm not asking you F of 2, I'm asking you what? I'm asking you the limit as x approaches 2, which means what number are we approaching? It's what? It is 2. This solid point, I know you think the answer should be 3. It's immaterial. That's what the book says. It's immaterial. It doesn't matter. You're approaching the number 2. You're getting really, really close. I'm not asking you what's the answer at 2. I'm asking you what are you approaching as you get closer to 2. You're approaching the number, the y value of 2. That's tricky. That is tricky. You okay? This is the one people get wrong on the test. Okay, some people went like this, yeah, I got it, and some people, no, I don't really get it. Again, all I can say is this, as you come closer and closer to this number 2, I mean, 2.0001 would still give you something close to 2. It's what you're approaching. It's not what you're going to get. Because Everett, he looked at this and went, well, when x is 2, I know I'm going to get 3, so he said the answer was 3. He's right. If I said f of 2 is 3. But the limit is 2. Okay? Sorry I had to hit that hard. I just feel like some of you get it and some of you don't. Okay, try these. There's 2 of them here. You probably don't know what you want to approach. Let's approach the number 2. So what's the limit of this function? Right down there. And then what's the limit of this one? F of x as x approaches 2. So do it twice for 2 and 2. All right, ready? See what's the answer to this one. 2.5. Okay, she says, kind of looks like the halfway mark, 2.5. Now remember, it is a number n. The definition said it's got to be just a number. Okay, and it's got to be approaching 2.5 and 2.5 from the left and the right. If I tried this answer right there, I'll get this one. This one, here. This one, here, here, here. We're moving which way? Towards what number? Yeah, we're moving towards 2 from the left. But from the right, we're moving towards what? We're moving towards 3. To be a limit, you got to be approaching the same number. Can't be split. Now, I know what you did, Cece. You just cut it in half, so 2.5. But it's got to be a number. So what's the limit here? There is no limit. Okay, D N E does not exist. You can write no limit, or just write D N E does not exist. Do you get why? Because from the left you were approaching 2, from the right you were approaching 3. It's not the same number.
But then how did that last one work?
Okay, let's
So
go back
then
to
the same thing.
let's go back to the last one. Ready?
Both lines were the same.
From the left.
That point was non-existent.
See this? But don't look at that point, because from the left you're approaching what? What are you approaching? 2. From the right you were approaching what number? 2. The actual answer, Chloe, if I said this, whoops. If I said that, f of 2, what's the answer? You look at 2, you go up, you go, oh, that's not the answer. That's the answer, 3. I'm not asking you f of 2, I'm asking you the limit of your function. Okay? And the limit is a number you're approaching. It's not the number you're going to get. Okay, how about this one? Jeff, what's the answer? As you're approaching 2 from the left, as you're approaching 2 from the right, are you approaching one number? No? So you're going to tell me what? DNE. He says DNE. Okay, let's look. So if you try 4, you get that answer, which is really 1.5. Try this one. This one. This one. This one. Now, as I get closer and closer to 2, look at my answers. Do they start to narrow in towards a number? No, actually, if I get closer and closer to 2, my answer gets what? Even bigger. I mean, can it get to 1 million? Why? What's? It's a what? It's the asymptote. Yeah. You guys, you might not remember this, but these are called rational functions, and that's when you have something on the bottom like this, x minus 2. When you're dividing by an x minus 2, 2 makes it 0 down here. You can't divide by 0. That's why you get these vertical asymptotes. So as you get closer to 2, it goes nothing but what? Up forever. As you get closer to 2 on this side, what's it do? What do all the answers do? Don't they get really what? As you go down, don't they get really small? I mean, it's unbounded. This thing goes to negative infinity. This thing goes to positive infinity. So you're not approaching any number. You're just going 2 different directions. There's no limit. All good? Jeff, you got it right. Okay. Good? DNE? All right. All right. These are the ones that are not graphed for you. Actually, that one is, but this one's not. So why don't you, right now, go ahead, use your graphing calculator. Go ahead and graph it. Okay? Then give me the limit as you graph it. Graphing.
Wait, what?
So where do you find the absolute value symbol? What button gives you that? Uh-oh. Oh, somebody said it.
Now.
Math. So we're going to go y equals, get rid of this. Here's x divided by, here's your button math. Go to what? Numbers. Okay, go to numbers next to it. Absolute value is number 1. Hit it. There it is. X divided by absolute value of X. Got it. There. Now I have it. Go ahead and graph it. To graph it, I'd hit zoom, and I'd hit number 6, which is your standard 10 by 10 window. There it is. Good? Where does, it's 2 horizontal lines. Where do they hit the y-axis? 1 and what? Negative 1. 1 and negative 1. Okay, so here's me again. I'm going to graph it. Okay, so here's 0. So here's 1 this way. Here's negative 1 this way. Okay, so there's a break in your graph, correct? Okay, why is there a break? It's the absolute value, okay. Kind of, yeah. Okay, the break happened right here at 0. If you put 0 in, you get what? 0 divided by absolute value of 0. Can you divide by 0? No. So right at 0, what's going on here? It's undefined, but what's going on then? When your function's undefined, that's when you get what? The vertical asymptote. Okay. Now, Skylar kind of said because it's an absolute value, it's broken apart. Remember absolute values, they were V's that go this way, or V's that go this way, up. Okay? But this is not a V, it's actually horizontal, horizontal. Okay. So, is this a solid point here? No, it's actually open. Is this a solid? No, it's open. Okay, so here comes the question. What's the limit? As you move in from the right side, if this is 10 and this is 5 and this is 2, what are you getting? What's your answer? 1, 1, 1, 1, 1. So to me, as you move in from the right, it looks like the limit is 1. But is it? No, because as you move in from the left towards 0, your answer is what every time? Negative 1. Can we say the limit is 1 and negative 1? No, it's got to be one number. So this one is what? DNE does not exist. Okay. Try that one. Number 2. What's the limit? And it would be probably at 3. What's the limit of this one as x approaches 3? Gavin, what do you think it is? It says does not exist. Do you guys agree? Come in from the right. You would be getting really close to what number? 4. Come in from the left. You'd be getting really close to what number? 2. Okay, that's not the same number. It's DNA. It does not exist. Okay? Try that one. This one's not graph for you, so graph it with your calculator. See what happens. So what was the secret in this one? Using parentheses, right? Tell your calculator I want x divided by what? That binomial. Okay? Hit graph. See what happens. Here it comes. Straight down, straight up. Okay? So I think we've seen that one.
I did not do that.
Yours didn't do that?
No, neither mine.
Do you use parentheses?
I did.
X divided by parentheses x minus 1.
Yes.
I just got a line.
Are you sure?
I got the,
You have it. That's exactly what I have. You have something vertical. That's the asymptote. That's the asymptote. Yeah. Yeah, you have your calculator draws a vertical asymptote, which looks confusing. Doesn't it go like this? Like that? Like this? Where's the vertical asymptote? Isn't it right here? So Hunter's calculator actually drew the vertical asymptote, so it looks really confusing because it's got a vertical line going up and down. His does. But he's got one of my older calculators. Okay, so what's the limit as you approach one from the left and one from the right? There's your answer. There's your answer. You're getting nothing but what? Bigger. Coming in from the left, what are you getting? Nothing but what? Smaller. So you're hey guys, you're going the opposite direction. Is there a limit? No limits. The next one, it's a sine function. Make sure you're in radians, and would you please close your window to a really small window, like a 2x2 window.
But make sure in radians.
Yeah, make sure you're in radians. No. I'll try to explain why it is.
What the heck?
I'm just going to copy this. Okay. Gavin's already done this one, so I'm just going to copy his. It looks like this, and then it goes wild on you, doesn't it? Then it goes something like that. Something like that.
What does mine not look like that?
I don't know. Doesn't it?
It's only wobbly for 3 turns.
Yeah, yours doesn't go as crazy as his did. Shrink your window down to 1, 1. Like just go 1 up, 1 down, 1 left, 1 right. I bet it will get a little more crazy. Yeah, you're good. It is going kind of nuts, isn't it? No? It doesn't happen? Yeah, maybe bring it smaller. Up.
No, it's Mim.
Oh my god.
All right, guys, look. What happens is you move in towards 0 from the left, from the right. Okay, as you keep moving in, guys, as you move in this way, it's up, then it's down, then it's up. By the way, the highest is 1 and the lowest is -1. It goes up to 1, down to -1, up, down, up, down, up, down. It's crazy. It's moving all over the place. So are you really approaching a number? No, you keep saying, was it 1? No, I don't know. Is it -1? Is it 1? Is it -1? Anytime your graph starts to oscillate up, down, you are not going to get a limit on this one. So this is your D&E. When your function goes crazy, up, down, oscillates, say no limit. I tried to show you 4 possibilities when you're not going to get a limit. They are, when your function oscillates, no limit. This one would be when your function what? Has a vertical asymptote. Are you listening? Okay, I think some of you are. How about that one?
Doesn't
Say again.
approach the same point.
Doesn't cross at the same point.
Well, doesn't approach the same point.
Doesn't approach the same point. Okay, I was looking for this. Do you guys realize this is a piecewise graph? Okay, are they connected? Are they continuous? No, they're what? What would that be called? This is like a continuous graph. What's this called? Anna, what's this called? Nope.
Oh, when they're not.
Kind of, yeah. But I'm saying this is a continuous graph. Even though it's a piecewise, when you start to do this, it's a broken piecewise graph. When you start seeing the broken piecewise, you kind of know it's not. There's no limit. Okay, this one. That would be another broken piecewise, wouldn't it? I mean, You guys, you have to pick up on the clues. This is when you're not going to get a limit. Okay, next up. Here's another piecewise graph, but it wasn't graphed for you. So I'm going to do it with you. Do you realize this function is called what? What's this one called? Say it again. Linear. It's linear. This one down here, x squared is quadratic. Okay. Everybody good? Linear just means it's a line, but it's only a line for what x values? 0 and a negative. So it's only a line for the negative x values. It crosses here at 3, and it goes this direction. Okay? Now it's only good for x values less than 0 or 0. That's why I put the solid dot. This is the quadratic part. It's only good for positives. So at 0, 0 doesn't count. That's why it's open. But it's quadratic, so it looks like that. It's the parent function. So if that is your graph, then answer these three limits. Try it. What's the limit of g of x as x approaches negative? X approaches 2, x approaches 0. 3 answers. What are they? And this is for sure on the test. And this one, it seems like students get 2 out of 3 right. For some reason, messes you up. There's one that is, and there's 2 that haven't. And you gotta look at what x is approaching.
Yeah, -2. Two different numbers.
Think about what I was saying. As x approaches -2, what are you approaching? What number do you approach?
What?
Okay. Who wants to try that one and tell me the limit as x approaches -2? 7 says Chloe. Let's see if she's right. Here's -2 right here. Okay, so you should know the answer to -2 is actually, one second, let me get rid of that. You should know the answer is actually that number. Now, are we approaching that number? Let's see. Coming in from the left side of -2, you would get this answer, this answer, this answer. So you're coming this way, approaching -2. Coming in from the right side, you'd be getting this answer, this answer, this answer. So you're approaching what number? This number. Is she right?
Yeah.
Is it 7? How'd you get it, Chloe?
I just did like, well, I knew the slope was -2, so I went like to 1.
Oh, you did this? Left 1, up 2, left 1, up 2?
Yep.
Yeah, okay. So she gets it that way, but could you have just what? Traced it?
Yeah.
With your calculator, yes. But there's still an easier way to do it.
Plug it in.
Plug it in. This is just an x value. -2 goes in. What's -2 times -2? 4. 4 plus 3? 7. Okay. What about this one? As x approaches 2, what is it? Okay. It's actually got to be this number, right? Over here. Okay. So as you approach it from the left, all you do is start climbing this way. From the right, you start getting these. So you're coming this way. What's the answer?
4.
Yeah. I did not do a very good job of drawing this to scale, because 4 would be where? 4 is up here somewhere. Sorry. Okay. Uh-oh. How about this one?
Does not exist.
Does not exist. How come? Because as you come in from the right towards 0, it looks like your answer is what?
0.
0. But if you come in from the left of 0 this way, you're approaching what? 3. You can't say two different numbers. Doesn't work. Does not exist. Okay? All right. There is one more way to find a limit, and that is using a table. So let me try to teach you this, and then we're pretty much done. Here is your function right here. If I were you right now, I'd type it in my calculator. We want to know what's the limit as x approaches 2. So what they did is they said, right here, if x is 2.1, 2.01, 2.001, I'm approaching from the right side of 2. Here I'm approaching from the left side of 2. So right now, you're going to use your calculator to fill in that table. So let's put that in, and it is okay, let's go here. Oh, there you go. Good. Okay. What did you guys do on the top? Did you use parentheses right away?
Yeah.
Okay, because you have to. Because you have to tell it, take the whole top, and then what? Divide by the whole bottom, right? X minus 2. Okay, so there I've got it typed in, right? I don't care about the graph. I really don't. I care about the table. So the table says if you get closer and closer to 2, let's try these numbers. How do I ask my calculator that? I go like this. Watch my hand, please. It's second table set. And if you guys could get your independent variable, that's your x variable, ask your calculator when x is whatever, what's y? So what you do is you get it to look like this. Independent variable, I'm going to ask my calculator. Okay, then I'm going to go like this. Second table, and now I see it's blank. You guys shouldn't be seeing anything. Okay, then I'll punch in 2.1, enter. 2.001, enter. 2.0001, enter. You just keep doing that. Get your 6 numbers. And as you see, the y values get smaller and smaller and smaller as they approach 1. On the other side, they get bigger, bigger, bigger as they approach 1. The table is telling me the limit is 1. If you actually graphed it, you would see it's 1. But there's 2 ways to look at a limit. You can graph it, you can use tables. Okay? So, would you guys agree that the answer is 1? There you go. Next one. Yeah. How do I get to the table? So like this. Okay, just tables right there. Second graph is the table. But Alec, if you want to ask it, did you see me do this? Yeah. Okay. All right. Okay, then go here. It says here sometimes, oops. This next one says sometimes the limits are rather obvious. I don't know. Are they really that obvious to you or not? Yes or no? I turned off the lights because I just felt like it wasn't, you weren't seeing it well enough. Help me. Why would it be rather obvious? Because it's only one function. Ooh, you're so close when you say that. Remember the ones that did not exist? Weren't they the ones that had the vertical asymptote? Also the ones that were broken and piecewise? What is that? That's a what? It's a parabola, and here's the big key. It's not just a parabola. It's not broken. It's a what kind of parabola? There it was. Somebody said it. Continuous. Do you guys know what this looks like? What's the plus 2 doing to your parent? Up 2. What does this 3 in front do to your parent? Stretches it. Makes it what? Actually skinnier. Okay, so it'd be kind of like this, wouldn't it? Like that? Good? Now, what's the limit? Why is it obvious? Because you're closing in on what number? -1. Doesn't it have to be this? Because from the right, all your answers would be approaching that number. From the left, your answers would be approaching that number. It's got to be this. What could you do to get it? Say again. Plug it in. Yeah, let's go like this. Plug that in. Now, 3 times -1 squared plus 2. What do you think that answer is? 5. The limit is 5. Okay. Why is it rather obvious? Because this graph was what? Continuous. Continuous graphs are so easy. It's the ones that get kind of broken up. Okay. Would the table have given you this?
Yep.
Yeah, it would have. I'm not going to do it with you. Okay. I think there's one more. Go ahead, get this one either by tables or by graph. Do it either way. I don't care. Just get it.
Well, it's a 0, but it's okay.
Does it do this? Just curious. Yeah? You people that graphed it, you might have saw that, which kind of tells you what? Coming in towards 1, either way, what's it approaching? Nothing. It doesn't get closer to any point. D and E. Did anybody do this one, the table?
That's an error.
Well, as you come this way and this way, I think this side you approach negative infinity, this side you approach positive infinity. What is it? D and E. Either way you would have got D and E. That's it. Okay, who owes me a quiz in this? Nobody. We're good. Make up quizzes from last Friday. If you want to make it up, stay here if you can. Or come in tomorrow night. Should have played basketball.
Ice sucks.
Okay. Here's the deal.